Hi everyone, welcome to my chemistry class once again. I believe you are enjoying following this class. First of all, permit me to say thank you to those of you that have been following me bomber to bomber, because I know that many of you have been following all the videos that I dropped. And I believe you are also learning very fast from following this channel. Thank you so much, and thank you for introducing it to your friends. Keep encouraging your friends to follow. They will not regret following this channel. To some of you that asked me to do the correction to the problem that I gave you last time to solve, I'm going to do it now. So I believe you are following. Keep following, then you will have every reason to celebrate at the end. Okay, now let's see the question. The correction to that question is here. So the question was, mention the change in oxidation number of zinc and copper from the reactant to the product in the equations below. The two equations are here. Question 1, you can see zinc plus this to give you this and this. Equation 2, copper plus this to give you this and this and this. So now, out of these two equations, they are asking you to give them the oxidation number of zinc in this first equation in the reactant and zinc in the product. The same thing here, copper in the reactant, copper in the product. So how do you do when you see a question like this? Just check the oxidation number. If it is a compound, calculate the oxidation number in the reactant and that of the product, then compare. Then you now know whether it's increasing or decreasing. Okay, but in this case, the first element here in the reactant they are just elements. The species here are elements, they are not compounds. It's in the product that you have them in the form of compounds. So what is very important, this one you don't need to calculate the oxidation, just look at it, you see the oxidation number of this and this. If it is in a compound here and a compound here, you calculate the oxidation number of here and that of here. But now that it's element, I told you that at every time when you see an element standing alone, like helium, the oxidation number is 0. Oxygen molecule, oxidation number is what? 0. What again? Sodium, the oxidation number is 0. The same thing with zinc, oxidation number is what? 0. Cu, 0. So any element standing alone, the oxidation number is what? 0. Having known that, you don't need to waste time calculating this. Know that these two are 0. Then come to the product, calculate that of this, calculate that of this, then compare them. So now, solution for equation 1. Since you are going to calculate zinc tetroxosulfate 6, get the oxidation number of zinc. Remember, I told you sometimes that the oxidation number of this radical is -2. This -2 is the oxidation number of the whole of this molecule or species. So where you have it here, you bring the -2. Since you are looking for that of zinc, you don't know that of zinc plus what? That of SO4, which is -2. Separate the plus and minus. It has no charge on it, plus or minus, nothing. So equate it to 0. Now, if you have done it up to that, work out for zinc. Now your zinc minus times plus becomes -2 equal to 0. Now your Zn, take this to this other side, it becomes plus 2. So your Zn is plus 2 in this formula. So the question was that you should do what? The change in oxidation number. So it's changing from 0. Remember I said this has oxidation number of 0. 0 to plus 2. That's the answer to question 1. So question 2. Let's see that of question 2 is still this that we are going to calculate. Cu into NO3 2. Okay, remember also that I told you that there's something that NO3, there's a species like this radical has oxidation number of what? -1. So in that situation where you have NO3, you put what? -1. So I don't know my Cu plus the NO3 that is -1. How many of these NO3 are there? There are 2. So equate it, since it has no charge on it, to what? 0. Then from there solve it, looking for your Cu. Plus times minus, 1 times 2, 2, equal to 0. Cu, take this -2 to this other side, it becomes plus 2. So this is the oxidation number of Cu in this compound. Now if that is done, the next thing is for you to compare from the reactant to the product, because that's the question. So the reactant, you have what? Oxidation number of a free element. An element is always what? 0, as I told you, and it's increasing from 0 to plus 2. Just the same way with equation 1. Okay, I believe the person that asked me to do the correction is following that steps, and I know those people will be able to solve some other time if they see a problem like this. So we are done with the correction of that problem. So let's go to the new business. Okay, now let's see this question. Which of the following pairs of species contains the same number of electrons? They have given you that oxygen is this, has this atomic number, this has this atomic number, as neon 10, sodium 11, magnesium 12, aluminium atomic number is 13, chlorine atomic number is what? 17. Remember I told you that all elements that do not have a charge, plus or minus, no plus, no minus, like in this case this one has plus, like in this case this one has plus, in this case this one has plus, in this case this one has minus. So anytime you see those ones that do not have plus or minus on them, the atomic number you are seeing here is also the same with the number of electrons. It's also the same with the proton number. But when it has plus or minus on them, they are not the same. Number of electrons is different from atomic number or number of protons. So now they are asking you which of these two, these pairs will have the same number of electrons. So this is the number of electrons. This is also the number of electrons of this one. But by the time, like in this case now, magnesium has plus. The number of electrons in this magnesium is not the same with this magnesium. Atomic number is still what? 12. But electron is different. This plus 2 means 2 electrons were given out. So you cannot say that after giving out 2, it will still be the same with this. So now let's write the electronic configuration of all these elements, then we will now know which one will have the same number of electrons. So solution. Let's start with A. A says magnesium 2 plus. Remember the atomic number is what? Atomic number of magnesium is 12. That's in a neutral atom of magnesium, it has 12 electrons. 12 electrons. So by the time the 12 electrons, if you remove 2, this plus 2 means it has given out 2 electrons. So if you remove 2 electrons from 12, how many is remaining? That's 12 minus 2, 10. So you write the electronic configuration to be 2 and what? 8. The next, on that same A, they said and what? And aluminium. Aluminium 3 plus. If you check there, aluminium, they said atomic number is 13. So 13 electrons when no electron left the atom. By the time it gives out 3 from 13, 10 is remaining. You write 2 and 8. This and this are the same. So A is correct. But if you care, we can do the next so that you see that other ones are not correct. Cl. That's for B. Cl, you have Cl to be Cl minus. It has gained 1 electron, meaning this minus means gaining. So it has gained 1 electron. 1 electron comes in, making the 7, because now it is 17. It has collected 1 to become this. So after 1 electron is collected, it is now becoming 18. So what electronic configuration you are going to write will be what? 2, 8, this is 10. 7 is remaining, plus this one that comes in, making 8. Okay, sorry for that oversight. So that is that. Now, if you do the one of its neighbor is what? Ne. Ne is neon. Atomic number is 10. No charge. So the same number of electrons will be written. 2 and 8. Are they the same? No. So this is 288. This is 28. So they are not the same. So if you do C, Na, Na there is what? 11. But when you check, you can see that plus 1 is on it, meaning 1 electron went out from it, remaining 10. So you write the 10 electrons. And now the next element is magnesium, and nothing is on it. So the 12 electrons are still there. You write 2, 8, and 2. So 2, 8, 2, 2, 8 is not, they are not the same. The last one, oxygen and sodium. Oxygen, they said, is 8. It has no charge here, so the 8 are still there. You have 2 and 6. Now the next is Na plus. Originally it has what? 11, but it has given out 1. How many is remaining? 10. So you write the electronic configuration of that 10, which is 2 and 8. Okay, so by the time you write that, you now see that this is 2, 8, this is 2, 6 and 2, 8. So they are not the same. The correct option remains A. I believe you enjoyed the lesson. You like the class. Keep sharing the channel. Invite your friends to join the channel, subscribe to the channel, and keep on following the channel for better performance in chemistry, in whether internal exams or external exams. Thank you and keep following the channel. See you some other time.